You ever been in the middle of a great conversation with a chatbot and then poof, it completely forgets what you just said 3 sentences ago? It is such a weird paradox, right? We've got these AIs that can write perfect code, compose poetry, even pass medical exams, but they have the memory of a goldfish. They're these superhuman geniuses, but they're also incredibly forgetful. Okay, so let's dive into exactly why this happens, and more importantly, how researchers are trying to build a better brain for AI. So, what's the deal here? Why are these unbelievably powerful models so bad at just remembering things? This isn't just some small, annoying quirk. It's actually one of the biggest hurdles in artificial intelligence today. It's the wall that separates a really clever tool from a truly adaptive, intelligent agent. This is what we call the memory problem. And honestly, solving it is the key to unlocking the entire next generation of AI. And the difference is just night and day when you put them side by side. I mean, think about it. Our human memory is a masterpiece of efficiency. It's adaptive, it grows with us our entire lives, and it's brilliant at figuring out what's important enough to keep and what's okay to let go of. Standard AI memory, though, it's just rigid, it's static, it's limited, and it becomes outrageously expensive to scale up. And the real kicker, when it tries to learn something new, it's prone to this thing called catastrophic forgetting, which is basically a fancy way of saying it just overwrites the old stuff completely. Now, this isn't some bug or design flaw. It's baked into the very foundation of the standard transformer architecture. First step is something called quadratic complexity. Okay, in simple terms, it means every time you double the length of a conversation, the computer power needed to process it doesn't just double, it squares. It gets exponentially harder. This leads directly to a fixed context window, which is a hard limit on how much the AI can see at any given moment. And finally, its knowledge is static. Once that training process is done, the world effectively stops for the AI. It's frozen in time. So, to solve these massive engineering challenges, researchers are doing something pretty smart. They're turning to the most sophisticated computer we know of, the human brain. Instead of just trying to brute force the problem with more and more processing power, they're looking at the elegant, super efficient systems that nature already perfected over millions of years. See, our brains use this brilliant multi-level system. It all starts with sensory memory. That's the ultra-fast buffer just taking in everything from the world around us. Then the important stuff gets handed off to our working memory. You can think of this as your mental desktop, your workspace for active thinking. And then finally, but really crucial bits get consolidated into long-term memory, which is this huge, durable storehouse. This whole setup is just incredibly powerful and efficient.
And that brings us to the core idea driving so much of this new research. Engineers are now building something called Memory-Augmented Transformers, and they are literally mapping the brain's architecture directly onto their AI models. So they're not just trying to build a bigger hard drive, they're trying to build an artificial mind with its own distinct interacting memory systems.
And here is basically the blueprint for that artificial mind. The AI's token embeddings, they act like our sensory memory, just stabilizing all that raw data coming in. The model's attention context, that limited window we talked about, that functions like our working memory, actively processing whatever's happening right now. And then new external memory banks are being bolted on to serve as a long-term memory, capable of storing and retrieving just unbelievable amounts of information. And just like our own memory isn't just one single thing, it turns out there isn't just one type of AI memory being developed. Some models encode knowledge right into their core programming, their parameters. Others use a state-based memory, holding info in their active neurons. A lot of them now use explicit storage, kind of like an external database they can search. But really, the most advanced ones are the hybrid systems, which cleverly mix and match all three approaches to get the best of all worlds. Okay, but here's where it gets really, really cool. These new memory systems, they aren't just passive storage buckets. No way. They are dynamic, active systems that can perform complex operations. It's not just about remembering, it's not actively deciding when to read from memory, when to write new information, and this is just as important, what to forget. This quote from some very recent research just nails it. It describes this fundamental shift, moving away from these static information dumps and toward adaptive, test-time learning systems. That means they can evolve and update themselves during a conversation, in real time, not just when they're being trained in a lab. It's a total game changer for how AI is designed. So, how does an AI decide what's actually important enough to save to its long-term memory? Well, it uses something called the surprise principle. It's pretty intuitive. Just like our brains tend to flag things that are new or unexpected, these AIs only trigger a write operation when new information is surprising, when it doesn't match what the model predicted was going to happen. It's an incredibly efficient way to learn because you're only focusing on the new, valuable stuff. Here's another concept pulled straight from neuroscience: consolidation. For us, this is the process that turns a fleeting experience into a stable, long-term memory. It's what happens when we sleep on it. AIs are now using a very similar technique called replay-based consolidation. By replaying important memories over and over, they can integrate new knowledge without, you guessed it, catastrophically overwriting what they already know. And the results from these new architectures are, well, they're staggering. I mean, forget remembering a few paragraphs. Some of the latest models, like one called RMT, can process a context of 50 million tokens. Let me put that in perspective for you. That is the equivalent of remembering and reasoning over the content of hundreds of novels, all at the same time. So this all leads to some pretty big, profound questions about where we're headed. We're moving beyond just building better chatbots here. We are starting to create truly cognitive systems. So you have to ask yourself, what happens when an AI never, ever forgets? The pace of progress here has been just breathtaking. I mean, think about it. Back in 2019, we were just laying the groundwork with some basic memory tricks. By 2022, we saw this massive expansion with models that could pull information from billions of documents. And now, as we're looking at 2025, we're seeing these ideas mature into these incredibly sophisticated hybrid systems that manage memory almost like a full-blown computer operating system. So what this all boils down to is a complete transformation of what an AI is. The ultimate goal, the ambition here, is to move beyond creating these static pattern recognizers that are basically frozen in time and to start developing truly adaptive, lifelong learning agents that can grow and evolve and learn continuously from every single interaction they have. And that leaves us with one final and I think pretty fascinating question. As we solve this memory problem, we're not just building a better tool, we're potentially creating something entirely new. So think about this. If an AI remembers every single conversation, every piece of data, every success, and every failure, what does it ultimately become?